Okay, this is part 2 of changes in population size. We're talking about studying population. The previous video was talking about how scientists determine the size of a population, and now we're going to talk about the changes in population size. So populations can change in size when new members join the population or when members leave the population. And there are ways that members join or leave the population, and one of those ways would be births and the other one would be deaths. So the main way in which new individuals that join a population are by being born into it. Now the birth rate of a population is the number of births in a population in a certain amount of time. Okay, so if you have 100 cottontail rabbits, they produce 600 young in a year, then the birth rate of the population would be 600 young per year. So the number of births, 600, the amount of time per year. That's the birth rate. Now, the main way that individuals leave a population is by dying. So the death rate is the number of deaths in a population in a certain amount of time. So if 400 rabbits die in a year, then that's your death rate, 400 rabbits per year. Okay, now you can write these in a population statement. So a population statement is one way to write about birth rates and death rates and how that's affecting your population. So if the birth rate in a population is greater, so if it's greater than the death rate, then the population size will generally increase. Okay, so you know that if the BR, the birth rate, is greater than the DR, the death rate, equals an increase. But if the death rate in a population is greater than the birth rate, then the population size will generally decrease. Okay, so over to the side you can say death rate is greater than birth rate equals decrease. We also need to talk about immigration and emigration. Well, what's the difference? Well, immigration with an I means moving into a population. So underline the I in immigration and the I in into. And emigration with an E means exiting a population. So underline your E's. So for example, I used to live in Westerville and now I live in Commercial Point. So I emigrated with an I to Commercial Point. I moved into the Commercial Point population, but I exited the Westerville population. We also need to discuss population density. And population density is the number of individuals in an area of a specific size. So you have an equation that you need to follow. It's population density equals the number of individuals divided by the unit area. So how do you figure that out? You might have a diagram like this one, which was in your book, and you would need to count the number of individuals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 flamingos. And you need to find out the area. So it's 4 meters by 2 meters. So that is 8 square meters. You divide that out, you would find that you would have 1.25 flamingos per square meter. So that way you could tell how dense your population is, how many are in a certain area. So you can take a look at the box to the left, and there you can see there's not as many flamingos. It's not as densely populated as the box to the right. The box to the right, you see there's many more flamingos in that box. So the population is much denser. You can see how they're kind of a little bit more crowded. You can think back whenever you're doing your owl simulation, you can see that some of the owls' nests that only had maybe 3 owlets were not as crowded as owlets who might have had, or nests that might have had 5 owlets. And so that is an example of population density. What was the population density of your nest? And you can figure that out by counting the individuals and dividing them by the unit area. The last thing we need to talk about are limiting factors. Now, a limiting factor is an environmental factor that causes a population to decrease. Now, make sure you know the difference between the death rate and a limiting factor. Death rate is just the number of deaths in a particular time period. Now, the limiting factor, that's the reason why people are dying. That's the actual environmental factor that causes people to die or organisms to die and the population to decrease. So know the difference, because on the pre-assessment, a lot of people were getting those two things confused. Now, here's some limiting factors that populations have, like food and water. Okay, now organisms require food and water to survive. Now, since food and water are often in limited supply, they are often limiting factors. Now, the largest population that an area can support is called its carrying capacity. Okay, so if a population exceeds its carrying capacity, there's too many people for the amount of abiotic and biotic resources that is available to the population, then your population is going to decline. So food and water, food is biotic, water is abiotic. There's not enough of those resources to support the amount of people or organisms that are in that specific area. Then there's not going to be enough to go around and people are going to starve. So you can see in this picture shows a child that lives in Somalia. And in Somalia, there's not a lot of abiotic and biotic resources to go around for the amount of people that live in that population. And so people are starving in that country because there's not enough for everybody. There's not enough water, there's not enough food. Those are abiotic and biotic resources that you need to survive. And so because there's not enough, then the population is going to decline. So those children are probably going to starve. But that's in nature's way to get the ecosystem back down to where the ecosystem can support a population and it has enough abiotic and biotic factors that it's at its carrying capacity or below its carrying capacity, because we know when it's over the carrying capacity, the organisms aren't getting the abiotic and biotic sources that it needs. And seeing what's happening in other countries, in third world countries like this, then you can see that's one example of how the population has exceeded its carrying capacity and there's not enough for everyone. That's very, very sad. But this happens, and it happens in nature, and I want you to be able to see that and what happens outside of our country. Another limiting factor is space. So space is another limiting factor for populations. Whenever you were doing your owl simulation, there wasn't a lot of space in your nest. Some of you might have even kind of shoved each other around and someone had fallen out of the nest so you could get more space. So space can be a limiting factor that could cause a population to decline. Another example would be with animals, the seabirds. If they're unable to find space to build a nest on a rocky ocean shore, then they're not going to be able to add to the population because they can't find a place to build their nest and lay their eggs and have their babies. So that will cause a decline in the population. Okay, now it also happens with plants. Plants need to have space. Now they need the right amount of space so that the plants are able to obtain sunlight, water, and soil nutrients. Okay, and all of these things are abiotic factors. Whenever the plants aren't able to have these abiotic factors, then they're not going to be able to grow as well as they should. When we moved to our house in Commercial Point, the person that lived there had too many shrubs altogether. They had they had all the shrubs planted so close that there's a big shrub that tried to grow and grow and grow and try to take away all the sunlight from the other shrub that was beside it. So we'd have like a really tall shrub, and then we'd have this little teeny shrub that wasn't growing because it didn't grow quite as fast as the one beside it, and it wasn't getting that sunlight and the water and the nutrients that it needed because it was trying to share that same amount of space with the plant right beside it. So that still happens in nature. If you could take a look at these sunflowers, you see that they're tightly packed together, and the sunflowers keep trying to outgrow one another so it gets more of the sunlight than its neighbor. And so that's one way that plants are trying to fight to get the space that they need. If they don't have the space, that's a limiting factor that could cause that organism not to be able to survive and grow. Another limiting factor is weather. Now, weather conditions like temperature and the amount of rainfall can also limit population growth. So, for example, like a cold snap in late spring, that could kill many young species of organisms like birds and mammals. It could also affect your plants. So if you have oranges that have already been growing on the trees and Florida has a cold snap, well, your oranges might not make it through. And that's a limiting factor where your population of oranges, the organism, would decline. Okay, you could also have a hurricane or a flood. And that could wash away nests or burrows. So another example, talking back to our owls and our owl experience, if those owlets were born and there was a cold snap, then the owlets could die because they might not have had enough feathers to keep them warm. And so that's another way where temperature could limit your population. Okay, so that's the conclusion of our notes for the second half, talking about limiting factors and how the populations can increase and decrease. If you need to rewind any part of this, go ahead and feel free to do so. Thank you for listening.